All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.4 in Pre-Calc. So this is trigonometric functions at any angle. And this basically jives with all the SOHCAHTOA stuff that we've been doing. So right now we've been dealing with angles on the coordinate plane that always have a radius of 1, right? So what if the radius wasn't 1, right? What if we have a radius that is r, right? Some number that's not 1. So the way we'd find the radius is basically by using Pythagorean theorem, right? We'd say that the one side of the triangle, right? One side of the triangle is x, the other side is y, right? And so x squared plus y squared equals r squared. That's how we get r is the square root of x squared plus y squared. And here r is positive because it just refers to the length of the radius. Eventually in math we'll talk about when an r can be negative for a radius, but for now it's positive. So if we use SOHCAHTOA, right, we would see that our, based on where our theta is, right, our y value is the opposite, and our radius is the hypotenuse, so opposite over hypotenuse is so, right? Ka would be the adjacent over the hypotenuse and so on, right? All of these jive with what we've already been doing. So let's go ahead and just do a bunch of problems. All right, so given the point on the terminal side of an angle in standard position, find the exact value of all 6 trig functions. So this is easiest if we look at where it lives, right? So negative 3, 4 lives in quadrant 2. 1, 2, 3, 1, 2, 3, 4, right here. So this is the terminal side, right? So what we want to do is we want to look at this triangle. And the triangle is always the triangle that goes back to the x-axis, not to the y-axis. So the reason for that is that the sine is always supposed to be the y value, so the side opposite the angle has to be the y value. So the y value here is 4, the x value is negative 3, and this is a 3, 4, 5 Pythagorean triple, right? You can also find that by doing negative 3 squared plus 4 squared, and you get the square root of 25, which is 5. But it's also totally fine if you spotted that this was a 3, 4, 5 Pythagorean triple. Right, that's great. All right. So once I know that, I'm just finding all 6 trig functions, right? So sine is going to be the opposite, which is 4, over the hypotenuse, which is 5. Cosine is going to be a negative 3 over 5, which makes sense because the x value is negative in quadrant 2, right? And tangent is going to be the opposite, which is 4 over the negative 3. Once I know those, I just flip the 3 of them to find my cosecant, which is going to be 5 over 4. My secant, which is going to be the flipped cosine, so negative 5 over 3. It doesn't matter if the negative is on the top or the bottom. And my cotangent, which is going to be a negative 3 over 4. Again, it doesn't matter if your negative's on the top or the bottom. All right, let's give it a try again. All right, so the next point is 5 comma negative 12. So again, I think it's helpful to draw it. You don't have to count out the 5 and 12, so 5, right, and then negative 12. This is the point we're looking at. Right? And once you realize that, again, we're always drawing the angle back to the positive, or back to the x-axis, right? So I realize this is a 5, 12, 13. If you didn't, you could do Pythagorean theorem to find that it is a 13, but it is definitely a 13. My r is the square root of 5 squared plus a negative 12 squared, which is definitely the square root of 169 or a 13, right? And then I just go ahead and do my 6 trig functions. So my sine is going to be the opposite side, which is the negative 12. Over the hypotenuse, right? The cosine is going to be the positive 5 over the hypotenuse of 13, and the tangent is going to be opposite, which is negative 12 over the adjacent, which is the 5. My cosecant is just going to be the flipped sine. Again, I don't care if the negative's on the top or the bottom. The secant is just going to be the flipped cosine, and the cotangent is just going to be the flipped tangent. Again, negative can go where you feel most comfortable. All right, so now we have some information. We're going to go ahead and find all 6 trig functions. Again, just like we saw in the last 2, I should draw this, right? So the first thing you want to do is you want to draw it, okay? So the first thing, so step 1, which quadrant? Because we don't have a point like we did in the last one. I need to figure out which quadrant, right? So I look and say, okay, well, tangent is positive. So here's what I've got. I've got that tangent is positive. Tangent is positive here in quadrant 1 and here in quadrant 4. Not quadrant 4, sorry, quadrant 3, I'm tired. So tangent's positive in these 2 quadrants because remember, tangent is a ratio of the x and the y. So in order for tangent to be positive, I need a quadrant where the 2 signs are the same. But then I'm told that sine is negative, right? So the second piece of information I'm told is that sine is negative. Well, sine is the y value. It's negative here and here. So the quadrant I must be looking at is quadrant 3. Right? So once I know that I'm in quadrant 3, I say, cool, let's draw this. So in quadrant 3, I know that I'm supposed to have the y is a 3 and the x is a 4, right? Y on top of x. So, but since I'm in quadrant 3, I recognize that they're both negative, right? My theta is always that angle between the terminal side and the x-axis, right, at the origin. That's always my theta. And I know that the missing side is a 5 because this is another Pythagorean triple, right? I have a 3, a 4 as the legs. That's going to be a 5. So now my sine should be the opposite, negative 3 over the hypotenuse, which is the 5. The hypotenuse is never negative. Again, eventually we'll talk about a radius being negative when we get to polar coordinates, but that's not until late in pre-calc, and it's a very different situation than this. Cosine would be the adjacent, which is the negative 4 over the 5. And the tangent is going to be a 3/4, but I already knew that because I was given the tangent, right? The cosecant is going to be the 5 over negative 3 because I flipped the sign. The secant is going to be the 5 over negative 4, right? And the cotangent is going to be the 4 over 3. And that's it, right? So again, when you're figuring out the angle in these triangles, it's always between the terminal side and the x-axis. That's always your angle, terminal side and the x-axis, okay? All right, let's give one a try. You can go ahead and try it if you want. So again, I need to draw it, right? And in order to draw it, the first thing I should do is figure out what quadrant I'm in, right? So in order to figure out what quadrant, I should probably look at the signs of the trig functions I have. So sine is positive, but cosine is negative. Well, the sine is the y value, so sine being positive, right? Sine being positive means the top two quadrants, right? But cosine being negative means the left two quadrants because that's the x value. So I must be in quadrant 2, right? And so I'm going to draw my picture in quadrant 2. So I draw a triangle. Remember, my theta is always that angle between the terminal side and the x-axis. I know that sine, right, of theta was 8 over 17, and I know that that's opposite over hypotenuse, right? So I have an 8 as the opposite and a 17 as the hypotenuse. I think, hey, this is a Pythagorean triple. It's 8, 15, 17. But because I'm in quadrant 2, it's a negative 15. Now, if you need to use Pythagorean theorem, you certainly can, right? You could have said x squared plus 8 squared equals 17 squared, and you would have gotten that x squared equals 289 minus 64. Yeah, which means that x squared is a 225 and x is a 15. And that's fine, right? Or you can spot the Pythagorean triple. But again, it's negative because of the quadrant I'm in, which is why it's important to do that work at the front end and figure out your quadrant. So now I can find all my trig functions. I already know sine is 8 over 17 because that was given to me, right? I know that the cosine should be the negative 15 over 17, and the tangent should be the opposite, which is 8 over negative 15. And then I just go ahead and flip all of them to find the other three. So 17 over 8 for the cosecant. The secant should be a 17 over negative 15, and the cotangent should be a negative 15 over 8. And that's it. All right, moving on. All right, so we're going to find all solutions to the equation sine of theta equals negative 1/2 for 0 to 2 pi. So this is basically asking you, where is the y on the unit circle a negative 1/2? That's what we're being asked, right? So when I look at the unit circle, I know sine is a half at the pi over 6's. Sine is a negative 1/2 at these 2 pi over 6's, right? So my answer is going to be that theta is this guy right here, which is 7 pi over 6, and this guy right here, which is 11 pi over 6. So 7 pi over 6 and 11 pi over 6. And those are my answers. Now, when we see this physically in class, it's really funny because people will be sitting at their desk, right? And they're sitting at their desk, right? That's their legs, and you've got your desk, and it's great. And your arms are like here and here. And the person next to you is solving a different trig question, and the person next to you is like, oh no, it's here and here. And the person next to that person is solving a different question. And so they're like, no, it's straight up. It's definitely pi over 2, right? So like this person right here, right? This person might be talking about these two angles, and this person might be solving this question, and this person might be looking for a pi over 2. And it's really funny, and you'll see people doing it with their arms when they do the unit circle. It's a little weirder when we do it, remotely, but it is what it is. All right. So P3, you're going to find all solutions on that same unit circle from 0 to 2 pi, right, of cosine of theta equals root 2 over 2. Remember, cosine of theta is the x on the unit circle. So this is asking you where is the x on the unit circle a root 2 over 2. So remember that x's, right, are positive on the right of the y-axis. So it's definitely not over here, right? I know that's out. And then I say, oh, the pi over 2 happens at all the, the root 2 over 2 happens at all the pi over 4s, right? So this is a pi over 4. And this, if I go all the way around, is a 7 pi over 4. And those are my two answers that fall in that interval. So pi over 4 and 7 pi over 4. And again, you'll see somebody sitting at a desk, right? And they'll be like, oh, it's these two. And then the person next to them will be like, oh, no, it's these two. Like pointing in the other direction, right? And of course, one of them's right and one of them's wrong. And then the person next to them will be like, I have no idea, it's these two, right? And there is a time when it's those two things for something, but not this. Anyway, so. All right, so now this one's a little bit trickier. So find all solutions to this equation. Again, so here, secant is 1 over the x on the unit circle, right? So what I would suggest that you do, there's a couple options, right? But I would suggest you solve for the x in the unit circle. So I'm going to get that 3 equals 2 root 3 times the x in the unit circle. 3 over 2 root 3, if I rationalize, is the same as a root 3, so it's a 3 root 3 over 6, which is a root 3 over 2. So I'm looking for where the x on the unit circle is a root 3 over 2, right? That happens here and here, right? Because this is root 3 over 2 comma 1/2, and this is root 3 over 2 comma negative 1/2. So my answer is going to be pi over 6 and 11 pi over 6. Another way to look at this, if you want to be a little bit lazy about it, to be honest, is you say to yourself, hey, it's got to be on the unit circle, right? Because Hogan's giving this to me to do by hand and find all the solutions. So if it's on the unit circle and it involves an x with a pi over, or with a root 3, and it's positive, you could kind of cheat and say, hey, it's got to be those two. All right. All right, so find all solutions to this equation. Now, again, you could probably find some shortcuts here, right? Remember that cosecant is 1 over the y on the unit circle. So if you were able to make a leap, right, if your brain said the following things, if your brain was like, 1, y is negative because there's a negative here, right? 2, y involves a root 2, then you could pretty much get here at the 2 pi over 4s down here really fast. You could get that this is, that's not 3, this is 5 pi over 4, and this is 7 pi over 4, and you could get there pretty fast. Is that cheating? Absolutely not. Congratulations. If you can do that, that's great. If you're like, cool, I can see that logically, since this is definitely a unit circle question, and it's got the root 2, and it's negative, and it's a y value, boom, it's got to be those two. Congratulations. If you can't see that, you'd solve, right? You'd get 1 equals negative root 2 times y in the unit circle, 1 over negative root 2, which is the same as a negative root 2 over 2 on the unit circle. And then you'd look at this and you'd say, oh yeah, that's where these two things happen, these two spots, and then your answer. So it's not wrong if you can make a mental leap. That's great. But, you know, worst case scenario, I'd ask you to communicate that leap, but I just did that here, right? It wasn't that hard to say y is negative, y has a root 2. All right, let's go ahead and try one with a tangent. So tangent's a little tricky because it's the y on the unit circle over the x on the unit circle. I'm going to write that as a negative root 3 over 1. So here's the thing. We saw this before. There's a couple things going on here. Number one, this negative tells me that I'm in quadrant 2 and quadrant 4. Because here's the thing. Tangent is only negative if x and y have opposite signs, right? And the only place that x and y have opposite signs, if you go here, right? So this is a no and this is a no because this is positive, positive, and this is negative, negative. So the only spots could be in quadrant 2 and quadrant 4, right? The other thing that we saw before was that root 3 is not on the unit circle, but root 3 over 2 is. So what I can do is I can multiply intentionally by a half over a half to look to see what this would look like on the unit circle. This on the unit circle would look like a negative root 3 over 2 and a 1/2. Now you might be thinking, cool, the y is negative, the x is positive, but remember, it doesn't matter where we put the negative. So we don't know whether it's the point where the root 3 over 2 is negative or where the half's negative. So what ends up happening is I'm basically looking for where the y on the unit circle is a root 3 over 2. That happens at the pi over 3's, so here and here, right? So that's going to happen at 2 pi over 3, and that's going to happen at 5 pi over 3. So my answers are theta equals 2 pi over 3 and 5 pi over 3. And again, you can see like this is the one where the y is negative. So this is the answer at 5 pi over 3, and this is the answer at 2 pi over 3. But you don't know if the negative's on the top or the bottom, so that's the issue. All right, cool. One last problem. So go ahead and try P1. You're going to find all solutions on 0 to 2 pi. So again, cotangent is the x on the unit circle over the y on the unit circle. So you're basically looking for where the x and the y are the same, right? So the x and the y have the same numerical value at all the pi over 4's, but in order to have the same numerical value and the same sign, it has to be here, right? So pi over 4 and 5 pi over 4, because they're both root 2 over 2 up here, right? This is a root 2 over 2 and another root 2 over 2. And they're both a negative root 2 over 2 here. So if you put the ratio of x over y or y over x in either direction, you get a 1. So my answer is going to be pi over 4 and 5 pi over 4. As an interesting side note, right, this spot, right, the spot we just saw, this is the spot where tangent is 1 and so is cotangent. This spot, the diagonal in the other quadrants, the pi over 4's here, are where tangent is negative 1 and cotangent is also negative 1. So just worth noting. All right. So one last thing, I'm not going to make you do anything with these in particular, but I just want to introduce you to the phrase so that it's not completely lost on you. You'll notice that technically when we were doing the angles in some of these, let's go up higher. So when we were doing, nope, farther up, so many of these problems. Like here, okay? So you'll notice that when we were doing here, technically the theta would be this whole thing, right? Like that would technically be theta, but we use this angle. That's called theta prime. It's a reference angle. Basically, when I was telling you earlier to draw the triangle back to the x-axis, that's called a reference angle. So you see that if we're using theta as here, right, if that's theta, we're actually going to use the triangle right here. So this thing is technically called theta prime. I'm not going to make you use that. I'm fine with you calling it theta. It works just fine. But technically, it's called a reference angle, and it's theta prime. To find the reference angle, you basically have to use whichever side of the x-axis you're on, and you have to either add or subtract theta based on where you're at. So in this instance, right, since this is pi and I want to be before pi, essentially what would happen is I would want the angle created when I do pi minus this theta, right? So that angle would be the bigger number, pi, minus the smaller angle, theta, and that would give me my reference angle. I don't need you to know this in particular, and you can see that in general, if you understand how the unit works and you have a calculator, there's no need to do reference angles because either you'll be able to find the angles on the unit circle, or if you can't find the angles in the unit circle, it's probably a situation where you can use a calculator. So I really don't think you're going to need this skill, but basically that's the idea. And you can see, like, so here, if you have a reference angle in quadrant 3, right, this is the angle you'd want, right? So in this case, you would do the theta, which is the bigger number, minus the pi, and you'd get this angle. So you can see that theta minus pi. And then if you had an angle in quadrant 4, right, you would want this little angle here. So you would take the 2 pi, which is the full circle, and you would subtract the theta. So you can see that it's 2 pi minus theta. You can logic your way through those, but again, I'm not really going to ask you to do them. So I just wanted to introduce you to the concept so that you're aware of what a reference angle is. Essentially, a reference angle is the acute angle that we use even if the angle, so if the angle is not acute, we use the acute angle in the triangle that is between the terminal side and the x-axis, and that's all. There you go, that's reference angles. So that's the end of this video.